Hello, all my dear students. Welcome to Sri Jain's Rank Zone classes. Students, my name is Ajay Gulati, and I am your friend and mentor for the mathematics portion, or I can say for the quantitative aptitude portion. This is what is the name for mathematics. Students, as you can see on the screen, we will be doing the geometry chapter in this class. So, dear students, let's start with class 05 for geometry. Today I will be discussing with you angle bisector theorem. Also, plus we will be discussing equilateral triangle remaining questions. Okay, few questions. There's one concept remaining questions. Okay, so let's start with this. Let's take the first question first. Then I'll move to equilateral triangles. Then I'll move to theorem. So just give me a small second so that I may fetch some questions for you. Yeah, just one sec, dear students. So question we have is the radius of the inner circle of an equilateral triangle having each side 6 centimeter is. What do we need to do? The radius of the inner circle of the equilateral triangle having each side 6 centimeter. See, dear students, what are we given? We are given side. Length of side is what? That is A. This is equal to 6 centimeter. Basically I prefer the color red, so let's take it red. Yeah, diagrams I'll draw by blue. Side is equal to A is equal to 6 centimeter. What is the radius? Small r is A by 2 root 3, or that becomes 6 upon 2 root 3. That is equal to 6. You can write as 2 into 3 divided by 2 into root 3. Finally, you will get root 3 as your answer. Okay, dear students, clear to all? I'm sure it must be clear to all of you. Let's take the next one. Yeah, dear students. So the next question we have is, this is the next question. If the incenter of an equilateral triangle lies inside the triangle and its radius is 3 centimeter, then the side of the equilateral triangle is, again, very easy question, dear students. What do we know? R is equal to A by 2 root 3. This implies A is equal to R into 2 root 3, or that will be, what is the value of R? The side of the equilateral triangle is, the R is 3. So I do 3 into 2 root 3, that is 6 root 3 is your answer. Okay, dear students. The next question is, the area of an equilateral triangle is 8 centimeter. The area of the region lying between the circumference and the in circle of the triangle is. See, students, what do you have to find? Again, a good question. Let's say we have a equilateral triangle first of all. Suppose I take a triangle. Suppose this is a triangle. Yeah. Now we have this equilateral triangle. Fine. The length of the side of an equilateral triangle is 8 centimeter. Fine. This is 8 centimeter. Okay. The area of the region lying between the circumference and the in circle of the triangle is, what does it mean? It means suppose I draw a triangle circle over here, and if I draw a circle like this is the circumcircle. Now students, the region between the circumference and the in circle is, see what is the circumference? The outer circle is the circumference and the inner circle is the in circle. So the region between this and this is the region between the circumference and the in circle. So this is the area that you have to, this is the area between that you have to find. Okay. Okay, assuming that it touches at this point. Okay. So what is the required area? The required area is big circle minus small circle. Okay. Big circle minus small circle. What is big circle? Big circle will be pi r square c. Here this will be capital R and this will be small r. Pi r square minus small circle pi r square. We already know what is r. R is equal to 2r. If I take pi common, what I'll get? 4r square minus r square, that is pi into 3r square. Clear? So 22 by 7 into 3. What is the value of small r? Small r is a by 2 root 3, or what is a? Side. So this is 4 by root 3. Clear? So it is 4 by root 3 square. That gives me 22 by 7 into 3 into. Now this 4 is what? This 4 is 16 by 3. 3 and 3 cancel. So that gives me 22 by 7 into 16. So far, clear to all? Okay. So now if you need to multiply 22 and 16, you can say 19 plus 3, 19 minus 3, that is 19 square minus 9. 19 square 361 minus 9, 352 by 7, or very easily you can read it as 350 plus 2 by 7. That will give you how much? That will give you 50 plus 2 by 7. This is your answer. Okay, dear students. There's one more way of multiplying these things. This is what? This is 3 1 by 7 into 16. So you multiply 3, you get 48. 16 into 3 plus 1 by 7 into 16 is 16 by 7. Getting it, or you can say 52 by 7. Whatever way you want, you can do it. Okay, dear students. Clear? Let's take the next one. An equilateral triangle of side 24 centimeter. A circle is inscribed touching its sides. The area of the remaining portion of the triangle is C, dear students. Let's say first of all, I draw an equilateral triangle. This is the triangle. I draw a vague circle. Mhm. Just give me a small moment so that I can adjust it. Now this is the circle. Okay, fine. This is the circle. An equilateral triangle of side 24. The side is 24 centimeter. A circle is inscribed touching its sides. The area of the remaining portion of the triangle is you have to tell this portion. So what is the shaded portion? The shaded portion is equal to triangle minus in circle. I should better write it. What is the triangle? The area of the triangle is root 3 by 4 into side square minus area of the incircle is pi small r square, that is root 3 s square by 4 minus pi. Pi is 22 by 7. R is s by 2 root 3 square, or I can say s square into root 3 by 4 minus, let me write it pi only, upon s square by 4 into 3. So this gives me what? This gives me an opportunity to take s square by 4 common. I write root 3 minus pi by 3. Okay, minus pi by 3. Now this calculation can be a bit lengthy, but still we'll do it. See, S is what? S is 24. See, the S is 24. So if I put S as 24, what do I get? I get 24 into 24 divided by 4 into root 3. What is root 3? Root 3 is 1.732 minus pi is 3.14 divided by 3. This I can say is 24 into 6. Okay, into 1.732 minus 3.14 divided by 3 will give me approximately 1.05. I hope all this is visible. Yes, it is clearly visible. Now, we are okay. So this gives me 24 into 6 into this is 1 point C. 1 and 1 cancel. 73 minus 10 is 0.68. 0.682 precisely speaking, 0.682. Now the other thing is, dear students, what are the options? Look at the options. Options are, uh, let me do the question in this space only. 24 into 6 into 0.682. If I write it like this, 24 into 6, can I read it as just for a second 0.666? 0.66 is what? 2 by 3. I am taking it a lesser number. I am assuming it to be a lesser number. So whatever answer I'll be getting will be a little bit lesser than the original answer. So this gives me 24 into 4 or 96. My answer will be a bit more than 96. Okay, so that gives me 98.55. So it's one more important thing. Other options are exact values. This is clearly very much decimal value. So this has to be your answer. You can solve it by whatever method you like. Okay, let me take the next question now. So the next question we have is, the centroid of an equilateral triangle ABC is G. Okay, we have an equilateral triangle whose centroid is G. Fine. Centroid is G and AB is equal to 10 centimeter. This AB is equal to 10 centimeter. The length of AG is, dear student, this is very easy actually. If this is the centroid, if I join this to this is R, this is G. AG is equal to R. R we know is how much? R is actually A by root 3. A by root 3 means 10 by root 3. Very easily you get your answer. This is your answer. Okay, dear students. So far clear? Now let's start with the concept for. So now, dear students, let's start with the theorem, angle bisector theorem. Let me take a triangle first. Suppose I say this is any triangle. Now, what happens is, suppose this is vertex A, this is vertex B, this is vertex C. Now here is the angle bisector. Angle bisector is something, a line segment which will divide this angle into two equal parts like this. Okay, dear students. Now this is the angle bisector. Suppose this meets the opposite side at the point D. Now what will happen if I say AD bisects angle A? Then what happens? Then as per angle bisector theorem, AB by AC, this side upon this side is equal to this segment upon this segment, or this portion upon this portion. Okay, dear students, that is equal to BD upon CD. Look, ABD, getting it? ABD, A A B D, then A C D. If you read it like A C D, getting it, dear students? Clear to all of you? So this is the theorem, angle bisector theorem. Directly, let's start with some questions based upon this. Okay, a very easy theorem. Find the value x given AD bisects angle A. So, dear students, the question given is this. This is 5, this is 3.5, this is 10, this is x. That was the inverted figure which I presented to you in front initially. So if I draw that figure again, it was like this. This is vertex B. This is like this. If this is BA, then this is BC. Now if this is AC, we have BA as 5, BC as 10, and from here if we have angle bisector, it divides it into two parts, suppose theta and theta. Then what is there? This is 3.5 and this is x. You have to find it. By the help of formula, you can also do it. See, 5 upon this as per angle bisector theorem. AB upon, let me write it like BA upon BC. BA upon BC is equal to, this is suppose D, is equal to AD upon CD. Okay. So what we have now, what is BA? BA is 5. What is BC? BC is 10. This is equal to AD. What is AD? 3.5. What is CD? CD is X. Okay. So from here, what do you get? You get X is equal to 3.5 into 10 upon 5. That is X is equal to 7. This is one way. Other approach which I use is, see, from here to here, if I move, this is double. Okay. So directly from here to here, if I move, that will also be double. 3.5 double. Therefore, x is equal to double of 3.5. That is x is equal to 7. Got it, dear students? Clear to all of you? Let's take the next one. The next question is, in the given figure, AE bisects exterior angle CAD. Now, a very, very good thing, one more good thing. See, let me explain it to you. What happens is, if I consider the case of an exterior angle bisector, okay, how do we do it? Look, let me take a triangle first. Suppose I take a triangle like this. Okay, now I produce the sides. Suppose I produce these sides. I produce this side like this. This is the angle which is, let's say, bisected like this. Okay, this is now A, this is B, this is C. Now this is the exterior angle. Okay, dear students, if you can recall, obviously you will be able to recall, if this is A, this is B, this is C. Here the interior angle meets, bisector meets over here D. Then what happens is, this upon this, let's say this is X. What do I write? I write basically AB by BC. AB by AC is equal to BD by CD. BD by CD. Exactly the same thing is valid over here, students. What? AB by BD. Okay, yeah. Again, AB by AC will be equal to same BD by CD. The same theorem is valid over here. It doesn't matter where this point is D. If this is the internal bisector, then this point will be D. If this is the external angle bisector, then this point will be D. But the theorem will remain to be same. That is AB by AC is equal to BD by CD. Again, I write AB. Here we have this angle bisector. Exterior angle CAD. This is the bisector. Okay. CAD is bisected by this angle and this angle are equal. Okay. So AB by AC is equal to AB by AC equal to BE by CE. Getting it, BE by CE. Any doubt? No doubt? Okay. What is the value of AB? 10. What is the value of AC? 6. What is the value of BE? BE is given to be 15. You have to find this. Let's say this portion is Y. This portion is Y. CE. CE is equal to Y. So what do I get, dear students? From here I get Y is equal to 15 into 6 upon 10, that is 90 by 10. Therefore Y is equal to 9. The moment you get this Y is equal to 9, what will happen? BC is equal to 15 minus 9. BC is equal to X is equal to 6. Okay. Let's take the next one. The next question we have is, in a triangle ABC, AD is the angle bisector and DM is the median. We have CM is equal to 3. Find the perimeter of triangle ABC. Okay, dear students. The thing is, see students, first of all, AD is the angle bisector. Fine. Now this DM is the median. When this DM is the median, students, what happens is, initially this section is not provided to you. Since this is the median, what it will do, it will divide it into two equal parts. If this is A, this will also be A. This is given to you as 3, therefore this will also be 3. Therefore AM is equal to AM is equal to MC is equal to 3. Since DM is the median, therefore AM is equal to MC, AM is equal to MC is equal to 3, or AC is equal to 6. Now, since AD is the angle bisector, AC is the angle bisector, therefore AB by AC, AB by AC is equal to BD by DC. Now we have everything. What is AB? AB is 5. We have AC as 6. DC we don't know right now. BD we know is 8. DC is X. From here I can say X is equal to what? X is equal to 8 into 6 divided by 5, or 8 into 6 divided by 5, that becomes 48 by 5, that is 9.6. So you get this X as 9.6. Now what to do? You need the perimeter. So the perimeter of triangle ABC is perimeter of triangle ABC. Perimeter of triangle ABC is, this is equal to AB plus BC plus CA. What is AB? AB is already given 5. BC is what? 8 plus X. CA is 3 plus 3 or 6. So X is what? X is 9.6. I should write it a bit spaciously. 8 plus 9.6 plus 6, that is 11 plus 9.6. 20.6 plus 8, 28.6 centimeter is your answer. And I'm sure, dear student, this all must be clear to all of you. Okay, let's proceed towards the next question. Let me get this next question for you. In a triangle ABC, AD bisects angle A externally. Okay, let me draw the figure. Now let's say this is A, this is B, this is C. AD bisects angle A externally. Let's say this is angle A. Now this is bisected. Okay, like this. This is D. AD bisects angle A externally. Add AC is 12. BD is equal to 20. From here to here it is 20. Yes, we do need this 20. Okay, then we are given CD as 10. This CD is 10 centimeter. Find AB. We have to tell this AB. Let's say this is X. Now, as per the angle, using exterior angle bisector theorem, using exterior angle bisector theorem, what will happen? Look, AB by AC is equal to BD by CD. Fine. AB is X, AC is 12, BD is 20, CD is 10. So your answer will be X is equal to 2 into 12, that is 24. Or the moment you see, student, this portion is double this portion, then what will happen? Then this portion will be double of this portion. 12, 24 is double. This is your answer. Okay, let's take the next one. I think I should start with the next type of question. This theorem we have done. Okay. Now the next question is that is based upon angle, bisector, and median altitude rule. Okay. See, very good type of question. And finally, I will tell you a shortcut for that, which you will love it, which you are gonna love. Okay. See, the question we have is in triangle ABC, angle B is equal to 60, angle C is equal to 40. Let me draw a triangle first. This is a triangle. Angle B 60 and C 40. Suppose this is vertex A, this is vertex B, this is vertex C. Angle B is equal to 60 and angle C is equal to 40 degree. AE AD is the bisector of angle A. Now here from here I draw AD that will divide this angle into two equal parts. Okay, AD is the bisector of angle A. AE is drawn perpendicular on BC from A. From here I draw a perpendicular line. This is A and this makes an angle 90 degree. Then the measure of angle EAD is you have to find the angle EAD. Okay, dear students. Let me tell you the direct shortcut first, then I will prove this question. The direct shortcut for this question is half of the difference of these two angles. Half of difference of other two angles of base angles. Okay, other of base angles. That is half of 60 minus 40. That is half into 10, or you can say half into 20, 10. Now, see how will I do it? Look, first of all, this is 90, this is 90. How much is this angle? Let's say this portion is 60, so this is 30. Before I proceed ahead, how much is this angle? This angle is 80 degree. 60, this is 60, this is 40. 180 minus 60 plus 40 is 80 degree. Now, other thing is this angle is 90. This angle is, first of all, how much is this angle? If this complete angle is 80 degree, this is half angle, this must be 40. Out of 40, this angle will be how much? This angle will be 80 minus 30 minus half of 80. Why? Because this is half of 80, this portion is 30, so only the remain this portion is 80 minus 30 minus 40, that is equal to 10 degree. You've got the direct shortcut. The next question which we are going to take, we will do it directly. Again, a very similar question. ABC is a triangle. Angle B 60 degree, angle C 40 degree, same. AD respectively. The bisector of angle A and perpendicular on BC. The measure of angle EAD is directly half of 60 minus 40, that is 10 degree. Next one. Next is also same. The measure of angle DA is again 10 degree. I think this is the examiner's favorite question. Okay, same favorite figure actually, favorite numbering. All clear? Okay, let's proceed ahead. Next, students, we discuss the Apollonius theorem. Now, what is Apollonius theorem? What does it say? See, students, Apollonius theorem is basically related to the median of a triangle. Okay, first of all, let me take any triangle. I will draw a median for this. This is the median. Now let's start with Apollonius theorem. We have Apollonius theorem. What does the Apollonius theorem state? Suppose this is a triangle ABC and this D is the midpoint. Okay, let it be M this time, so that you may not get confused. M is the if M is the midpoint of BC, then what does the theorem state? The theorem states AB square plus AC square is equal to double of AB square plus AC square is equal to double of what? Double of this median, that is AM square, plus any of this portion, this or this, whichever portion you want to take, that is plus BM square. Double of AM square plus BM square, that is, this is the theorem. AB square plus AC square is equal to double of AM square plus BM square, or you can also say CM square. Now let's start with the questions. So the next question for the next topic is, dear students, now the question for this topic, Apollonius theorem, is in a triangle PQR. We have any triangle PQR. Let me draw the triangle first, then I will move ahead. I have this triangle. In this triangle PQR, PQ is equal to 30, QR is equal to 36. Okay, like this. See, I take PQ is 30, QR is 36, PQR, PR is 50, D is the midpoint of QR. Just give me a second. Fine, so no problem, dear students. It will be better if I take QR over here. This is suppose QR, let's say this is P. PQ 30, QR is 36, and PR. This PR is equal to 50. D is the midpoint of QR. Let's say this point is D. This is equal to 36. Now D is the midpoint of QR. Then what is the length of CD? What is the length of this CD, given that C is the centroid? We will come to the C later on. We will come to CD later on, but let's start by using Apollonius theorem. Using Apollonius theorem, what do you get? You get AB square, sorry, PQ square plus PR square is equal to double of PD square plus QR square. Okay. Now what is PQ square? PQ square will be 900. PR square will be 2500. Double of PD square you require QR PD square plus QD square, it will be okay. I told you can take this section or this section, whatever you want. Okay, that is QD square. QD is 18 square. 18 square is 324. Let me directly write 324 only. Now this together is 3400, divided by 2 will be 1700, is equal to PD square plus 324. I have cancelled this 2 with this. If I further subtract this 2, this will be 1700 minus 324. This is what? This is PD square. This is how much? 76. 17 minus 3 is 14. Then this is 1376. So far clear? Yes. So your PD square is equal to 1376. Therefore, this I can write as 1376. I can see this is divisible by 4. Let's write it. PD square is equal to 4. Let me write it 4 into. If I divide this by 4, it becomes 3, then 17. 4, then 1 6, 44. I can write this as further. This is 4 into, this is easy, 86. So PD is what? PD is actually, if I take the under root, PD will be what? PD will be, PD will be 4 into root 86. What do you require now? This is C. This is CD. We know that CD, since this is the centroid, CD is equal to 1/3 of PD is equal to 1 by 3 of 4 into root 86. Do we have any such option? 4 root 86 divided by 3, option 1 is the answer. Clear, my dear students? Okay, next one. In a triangle XYZ, you read the question, by the time I'll draw the figure. We have we have x, y, 22, x, z, 14, y, z, 28. Xm is the median. Xm is the median. Okay, let's say this is the median. This is the point M. So this will be 14. This will be 14. What is the length? Find the length of xg. Okay, G must be the centroid which hasn't been marked. Okay, G must be the centroid. XG, find the length of XG. G is the centroid of the triangle. So what will happen, dear students? We know, using Apollonius theorem, xy square plus xz square is equal to double of ym square plus xm square. So that gives me xy square. 22 square is 484. This is 196 is equal to double of ym is, see students, ym is again 14, 14 square plus x m square. So what does this give me? This gives me 484 plus 196. I am not cancelling 2. Why? Because it will make my life easy over here. 14 square plus 14 square plus 2xm square. This is 484. This 196 and this will cancel. Minus 14 square is equal to 2xm square. So that gives me 484 minus 196 is equal to 2xm square. So far clear? Okay. So this is like 242 minus 98 is equal to xm square. 242 minus 98 will be, C, very easily it will be 144 is equal to xm square. From here I get xm is equal to 12. This complete is equal to 12. Now I know this is 1/3 and this is 2/3. Therefore xg is equal to 2/3 of xm, that is 2 by third of 12. 3 and 12 cancel to give me 4. 2 into 12 will give me 8. So xg is equal to 8 centimeter. This is your answer, my dear students. Clear? You have got the Apollonius theorem in detail. Now let's move to the next concept. Should we start the next topic? I think this class is already more than 45 minutes, so we should wind it up. Well, students, I hope all this is enough for today. We have done two topics in this particular class. So I should wind up today. In fact, we have done three topics in this particular class: Apollonius theorem, then angle bisector theorem, and also we did some question of equilateral triangle. So this is enough for today. You kindly practice whatever I'm teaching you. It will help you a lot. Until unless you practice, you won't be able to solve the questions in your exam. So make sure that whatever I teach you, you give enough time to practice. You take enough time to practice these questions by writing. There's no harm in writing these questions twice or thrice. Revision will make you expert of the subject. Believe me, a teacher is good only because he does a question many times. A teacher is fast with the question because he does a question many times. I know you have limited time, but believe me, students, you have to practice these questions. You have to revise them again and again so that you can crack them in your exam in little time. Okay, that is the most important thing. Solving a question by consuming a lot of time is never advisable. So, from my side, I will say please practice as much as you can. And now I take your leave. Goodbye. Bye bye. Take care. We will meet again tomorrow.